Day 2, presentation, Summer Algebra. Today we're going to be doing a lot of graphing. I'm going to use a different tool, a document camera today, in addition to using the sketchpad that we used yesterday. So let's get on with it and let's learn about some graphing. Again, we're going to be doing graphing over a couple of days. Today is just the first day of graphing, so we're not going to do everything in this video, but we will do a lot. So let's move on and let's get to our sketchpad. And let's just do a little overview of what we're going to talk about today. So we're going to start with talking about well-formed graphs. Okay, so in a well-formed graph, we have a, let me get my pencil size right here. We like to draw with 3.5 and KB in blue. So when we talk about well-formed graphs, we're talking about drawing an X and Y axis, our Cartesian, that's our Cartesian plane, our Cartesian plane, or our coordinate plane. We label our axis. We identify good intervals so that the data fits on our graph. We make sure the interval is consistent on each axis. We plot and label each point. And then we draw a line if the relationship is linear to represent the data in our graph. Now, the second thing that we're going to do when we cut over, we're going to do all of this. We're going to do all of this work on a document camera here in a second. The second thing we do when we calculate slope, the slope of a line, once we have this calculating the slope of a line, is we identify the change in y over the change in x. We can write that as delta y over delta x, or we can write it if we have 2 points, x2 comma y2 and x1 comma y1. If we have these 2 points, we can calculate the slope by taking the difference in our y's and then dividing by our difference in our x's. The units of our slope are going to be our y units over our x units. So if our y-axis, let's just say we have a graph here and we have, minutes on our x-axis, and our y-axis we have, yards, then our units of our slope after we calculate the number is going to be our y units over our x units. We'll get to all of this when we come back to this on our document camera. And then just a note that we're not going to really get to today, but we'll get into over the course of the next few days, is that when we talk about the slope and the rate of change, and we're talking about a word problem, and we're looking for what the key that will give us that rate of change. If we find that word per, like miles per hour or dollars per day, that's going to be the thing that also identifies our slope. But we can just come back. Let's put a pin in this one and come back to it later. Now what I want to do again is I want to come back and I want to go over our, we're going to go to our document camera. Okay, now we're on our document camera. So that's what we're seeing here. Let's just see. Yeah, so we're looking at our document camera. Whoops, just a sec. Let's just make sure we're doing the right thing here. Yeah. Okay, so this is our first problem. We want to do a well-formed graph, and we want to graph the following data. So we have this person who's saving, on day, and this is by day. So on day 5, we know the person has $45. So this is our dollars saved. In this column we have our dollars saved, and on this column we have the day. So on day 5 we have $45. On day 7 we have $55. On day 10 we have 70, etc. So generally we like to graph this first column. We put this on our x-axis, and our second column is our y-axis. So the first thing we're going to do is we're going to draw our x and our y axis. So we're going to take out our ruler and we're going to use our graph paper here. Now the other thing to notice is that there's two kinds of graphs in general. One is where all the numbers are positive. If all the numbers are positive, can you have a negative dollar saved or a negative days? Generally not. So what we're going to do is we're going to do most of our graphing in what we call quadrant 1. So we're not going to even bother drawing a graph that has quadrant 2, 3, and 4. So this is quadrant 1. This would be quadrant 2 over here, quadrant 3, and quadrant 4 if we had a graph that went in both directions. But because we know the numbers are positive, we're just going to stick with quadrant 1. So now we've drawn our x-axis and our y-axis. Now, because this data we have has labels on it, we're going to label our axes. That's point 2. Days, and this is going to be dollars saved. All right. Okay, the third thing that we want to do is we want to make sure that we have our data will fit on each axis. So let's see. Our days, our smallest number of days is 5. So we can go down to 0. So we always start at 0 on these graphs. In some science classes and some graphs you may have seen, they have breaks in graphs and they don't necessarily start at 0. But in math, at least for this year, we're always going to start at 0. So this is 0 going up for our y and 0 for our x. Now, if we want to fit 12 days on here, we have to make sure that we can fit 12 days. So can we fit 1 on each tick mark? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. So we can fit each interval, each tick mark can be 1. So we don't have to label each one, but we just have to make sure each one is consistent. And our max data here is 12, so we can put a 12 right here. If you wanted to label each point, you could label each tick mark, but we don't have to. Now, on the y-axis, notice if we started with 1, 2, 3, we wouldn't make it to the top. We would go all the way. We'd be way, way up here. So what we have to do is decide how we're going to count. Can we count by 5s? Well, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 50. Nope, can't count by 5s. So we could be safe if we counted by 10s. We have to make sure that all of these numbers are going to fit. So let's try 10, 20, 30, 40, 50. This is going to fit. 60, 70, 80, 90, 100. So at least this data will all fit. Maybe you wanted to count by 8s or something, but counting by 10s is easy. So now and notice, each of our intervals has to be the same. So, and these are called intervals. This is our interval. Interval of 1, interval of 2, interval of 3. But each one is 1, 1, 1, 1, 1. It's plus 1, plus 1. And here, each interval is plus 10, plus 10, plus 10, plus 10. See, these must be the same. Each distance has to represent the same number. So you can't start down here at 50 and go 50, 60, 70, 80, 90. Each one has to be 10. And that's an important thing that some people make a mistake on. This is critical. Mistakes are made here. So be careful. I'm warning you. All right, next, we're going to plot each point. So each point is is marked by the x and the y coordinates. So this is 5, 45. So we go over 5 and up 45. Now notice this is 40, so 45 is right here in the middle. We'll label our point 5, 45. Then we have 7, 55. We have 10, 70. And then 12, 80. Now notice, this appears to be a linear relationship, and because it appears to be a linear relationship, we're going to draw our line through these points. It starts here, and it goes forever in this direction. Why doesn't it go in the negative direction? Because you can't have negative days. All right, so this represents savings. It's a well-formed graph. We have labels. We've labeled our x and our y. We have consistent intervals. We've labeled our intervals. We could go ahead and label every single one if we wanted to, but we don't have to. And this is very easy for me to read. Okay, good. So we've constructed a well-formed graph. This may very well appear on your quiz tomorrow, so keep your eyes open for that. All right. Now, the second thing that we're going to do is we're going to find the slope and y-intercept in example 1. Now, remember, the slope can be found by, it's the change in y, and I'm going to do this both ways, in a couple of different ways. Change in y over change in x. So, and that can be any 2 points between any 2 points. So we have 4 points on this graph. We can choose any of them. So let's just take maybe these 2 points. Let's try this one and this one. And to find the change in y over the change in x, we're going to take a point right here that's horizontal to one point and vertical to the other point. And we can see that if we go from here to here, our change in y is here, and our change in x is here. This is the difference in the 2 y's. This y is 45, and this y is 70. So our change is 70 minus 45. And that's 25. That's our change in y. Our change in x is 10 to 5. So that's 10 minus 5, which equals 5. Okay. Now, if our change in y is 25 and our change in x is 5, then our slope is 25 over 5. So our slope is 5. But we need our units. Now remember from the early, we still need our units. Our units are our y units, our slope units, or our y units divided by our x units. It's the same as the change in y over the change in x. It's that y over x, but now we're going to take our units and divide by our units. So our units are dollars saved, our y units, and our x units are days. So we can read that as dollars saved per day. So our answer to our slope is $5 saved per day. Or we can put our dollar sign out here. So this person is saving $5 every day, which makes sense because if on day 5 they had 45, then on day 6 they'd have 50 if they saved 5. And then on day 7, they'd have 55, another 5, and they consistently save $5 every day. Okay, another way to calculate slope is simply, you can use your slope formula, which is m equals y2 minus y1 over x2 minus x1. And let's just use 2 other points just for fun. Let's use these 2 points. So we'll call this our second point. We'll call this our first point. So our y2 is 80. Our y coordinate for our second is 80. Minus our y1 is 70. Our x2 is 12. And our x1 is 10. So that's equal to 10 over 2, which is also equal to 5. That's cool. You can use any 2 points, and you'll always get, on a straight line, you'll get the same slope. And in this case, the slope of this line is 5. Now, where is our y-intercept? Our y-intercept, so that's our slope. That was our slope. And now our y-intercept is where the line intercepts or hits the y-axis, right here. So that's at 20. So our y-intercept is $20. Okay, or 0, 20. However you want to think about it. It's the point 0, 20. It crosses the y-intercept at 20. And so the y-intercept is also known as our starting point. We'll talk more about this as we go talk more about word problems and such. But the y-intercept starting point, where the line hits the y-axis, it's all the same thing. All right, now, so that's all we're going to do here on our document camera. Now we're going to move into some other concepts and that we did in class today. But hopefully this all makes sense. We're going to come back to this slope formula in a little bit and do some more calculations on slope. Okay, so let's head over to our sketch pad. Here we go. Okay, so we talked about constructing well-formed graphs and calculating the slope of a line. So let's keep moving forward. Now let's start talking about smart graphing choices. So this is a different topic that we talked about today. And this is what we're talking about. We're graphing using t-charts. So we have the equation of a line that's written in y equals mx plus b form. And we're trying to calculate, we want to generate some points. So the way that we generate points is we choose some x values, and then we calculate their y values. And then we build ordered pairs, and then we graph them. In this case, we're not going to do the graphing. We're just going to generate some points. So let's do an easy one. So let's start with like y equals 2x plus 1. So in this case, if x, we'll choose some points like 0, 1, and 2 for x. We'll plug them in, 2x plus 1. So 2 times 0 plus 1, and we'll get our y. In this case, we have 1. So in 2 times 1 plus 1 is 3. 2 times 2. We did all this in class today, so I'm trying to get to the harder stuff here with my examples, but I'm just reminding you what we did. That's a y of 5. So our points that we would graph in this case are 0, 1, 1, 3, and 2, 5. If that was our equation. Now over here, we could do 0, 1, and 2. We could do 0, 1, and 2 for our x, but watch what happens. If we choose a 1 for our x, we end up with 2/3 times 1 plus 2. And so that's 2/3 plus 2. And so we get 2 2/3 for our y. We don't want fractions. We want to avoid fractions. That's our whole goal here. So let's not do something hard like choosing 0, 1, and 2. Well, let's do this instead. Let's choose 0. But what integer could I plug in for x in such that y will be a integer? It'll be a whole number. It'll be an easy number to work with. Well, let's choose an x equal to 3. And why did I choose x equal to 3? Because I know that 2/3 times 3 is going to equal a whole number, or 2. So what's another good number I could choose to multiply by 2/3 and know that I'm going to get a whole number? So for those of you who said anything divisible by 3, like 6, those are good choices. So let's see what happens. 2/3 times my x of 0 plus 2. Well, that's going to give me 2. So my ordered pair is 0, 2. 3, I get 2/3 times 3 plus 2. So I'm going to cancel there. And I get 2 plus 2 is 4. So my ordered pair is 3, 4. And here, if I go 2/3 times 6 plus 2, I get 6. So my ordered pair is 6, 6. So these are the points that I would graph. Now we're not doing the graphing right here, but the smart graphing choice is starting with your x's that are divisible by 3, which is the same thing as the denominator of the coefficient. Right? So the coefficient here is 3, so I want all my x's to be divisible by 3, which will give me nice whole numbers for y. So let's do the same thing here. And let's make some good choices. 0 is almost always a good choice because 0 times -2/5 will give me just a 7. Right? Because -2/5 times 0. But what other choices am I going to do? And the key is to look at this denominator here. So I want you now to pause and try. Pause and try. And so for those of you who said, I want numbers divisible by 5, are right. So let's choose 5. And let's choose maybe, how about -5? That's divisible by 5. We could have chosen 10 or 15. So let's see. -2/5 times 5 plus 7. Well, that's -2 plus 7, or 5. My ordered pairs are 0, 7, and 5, 5. And here, I get -2/5 times -5 plus 7. My negatives cancel. Cancel, I get 9. And so -5, 9. And those are my ordered pairs. And if you want to graph them, these will all create lines. These will both create lines because we have equations that are written in the form of y equals mx plus b, where b and m are any numbers. Anything that can be written like this will be a line. Good. So that's smart graphing choices. Let's move along and let's cover another topic that we did in class today, and that is what's in slope-intercept form. Remember, y equals mx plus b is slope-intercept form. So that means m can be any number, and this positive b, also y equals mx, really minus b. That's the same thing. So which are in y equals mx plus b form? This is very straightforward. Well, and then if so, what is m comma b? Well, this one is mx plus b form, our m and our b. Yes. M equals 2, b equals -4. This is our y-intercept. This is our slope. Now, I want you to pause plus try. I want you to pause and try. Okay, this one is no. Yep, this one is no. This is not in y. This is not in that form because it's not y. This is x equals 2 times y minus 1. This is also a no because our x has to be over here and our y cannot have a coefficient. It has to be just y by itself equals mx plus b. Now this one here, y equals 4, this is actually in y equals mx plus b form. So those of you who caught it, because this is like y equals 0x plus 4. But you don't write this because it simplifies to just y equals 4. So in this case, our m equals 0, and our y-intercept is equal to 4. Likewise, this one is like y equals 2x plus 0. And in this case, our m equals 2, and our b equals 0. So these are both yeses. And this last one is also a yes. It's just that they're fractions, and fractions are just fine. So our m is equal to negative 6 over 11, and our b is equal to negative 4 ninths. So let's just commit to all those answers by boxing our answers. And let's move on. Very good. We're making great progress today. Okay, so let's convert these to slope-intercept form. So remember, this is just like we did in lesson 1. We talked about this is like solving for y. It's rearranging formulas. So to do that, we have to get our x on, what I say, get our x on the right. So we'll subtract 3x from both sides. So we get negative 5y equals negative 3x plus 15. Now we'll divide both sides, everything by negative 5. Okay, remember the key point here. When we divide our right side by negative 5, we have to divide both pieces, both terms, by negative 5. So our left side is y, and our right side is, we cancel, 3/5 x. And our right side is 5 divided by negative 15 is negative 3. So plus a negative 3 is the same thing as just minus 3. So this is now in slope-intercept form, where our slope is 3/5 and our y-intercept is negative 3. Okay, let's do this one. Oh, this is interesting. Let's get those x's over to the right. Subtract 11x to both sides. We get 22y equals 66x minus 88. Divide everything by 22. Now, instead of just dividing, I could write my 22 here and then separate them. Or watch what I can do. I can just divide by 22 like this. Just kind of save a step. Our m equals 3 and our y-intercept. Why do we use b? I'm not sure. That's just the convention. Minus 4. And so these are now in ready-to-graph form. And we'll talk about that ready-to-graph form tomorrow. Okay? So now let's talk about graphing using intercepts. So this is something where it's kind of a quick and dirty way of graphing, and we're going to do 2. We're going to do 2x plus 5y equals 10, and then we'll do negative 3x plus 4y equals 24. We'll do that one. Okay, so let's draw our axes. Whoops, that's too thin. Let's make that a little thicker. There we go. All right, let's finish off our neat graphing and do our arrows. Now, the idea of using graphing using intercepts, as we talked about in class, is we got to find where we cross the x-intercept and where we cross the. Let's do this one here in a different color. We'll do this one in a different color here in a second. We want to find out where the x-intercept and where the y-intercept are. So we want to find our x-intercept and we want to find our y-intercept. That's the key. So our x-intercept is where y is 0, and our y-intercept is where x is 0, right? So y-intercept, here, let's write that over here. Y-intercept is where x equals 0, and our x-intercept is where y equals 0, right? Because our y-intercept is where a line crosses the y-axis. So anywhere where any line crosses the y-axis, the x-coordinate is 0, right? Our x-coordinate is here. It's 0, 2/3. Here it's 0, 3 1/4. Here our point is like 0, -3 1/2. Right? But in all cases, our x is 0. And likewise, for our x-intercept, our x-intercepts, our y-coordinate is always 0. Here it's -3, 0. Here it's 1 1/2, 0. And here it's 4, 0. And in all cases, our y value is 0. So that's why when we're making our graphs using intercepts, we can just say, well, let's find out where our y is 0 and our x is 0, and then we can find 2 points and then draw our line. So let's watch how that works. So if y is 0, well, I say, well, 2x plus 5 times 0 equals 10. Because if y is 0, I plug 0 in for y. So I get 2x equals 10. So x equals 5. And likewise, when x is 0, so 2 times 0 plus 5y equals 10. In this case, I get 5y equals 10. Y is 2. So if I plot those 2 points and I go 1, 2, 3, 4, 5, 0. And here I go 0, 2. I can now draw my nice line. Cool. Right? Because all I need to do is find 2 points. And often the y-intercepts and the x-intercepts are easy points to find. So let's do the same thing now. We'll do this other one in orange. So we're going to find our x and y-intercept again. So what do? We find our x-intercept where y is 0 and our y-intercept when x is 0. So now let's plug our 0 in for y. -3x plus 4y equals 24. And our y is 0. So we get -3x equals 24. So that's -8. And then when x is 0, we say -3 times 0 plus 4y equals 24. And if you solve that, you get y equals 6. So let's plot those. 1, 2, 3, 4, 5, 6, 7, 8. So here's -8, 0. And then 0, 6. 1, 2, 3, 4, 5, 6. Now to draw a straight line between those 2 points, simply do that. And there we have it. We've graphed our orange line. This is our orange. And then we've graphed our blue line. Here. So that's graphing using intercepts. Doing great. 2 more things. So we're just going to find the slope of lines containing 2 points. So we're not going to graph these 2 points. We're just going to find the slope of the line containing these 2 points. And we're going to use our slope formula. y2 minus y1, the difference in our y's over the difference in our x's. So the difference in our y's, we're going to use the second point first. We don't have to. We could use the first point first, but we have to do it the same in both cases. So start with our 7 minus 0 and then 4 minus 0. And so we get 7/4. Okay, we're going to start with our y's. Sometimes you can draw the arrows. Make sure the arrows go from the same y's, start with the same point. And this way you kind of don't screw it up, because you'll remember to start with the same coordinate, because I can't take -3, subtract 2, and then on the bottom take -2 minus 3. I have to use the points in the same order or I'll get my sign wrong. So we take -3 minus 2 over 3. Now don't get this wrong, minus, and what's our x-coordinate? Minus a -2. So here we got -5, and then here's subtracting a negative is the same as adding a positive over 5. So that's -1. Let's do this one more time. Y's, x's. 3 minus 3 over 8 minus 4. Oh, wait, what's going on? We have 0 over 4. Well, that's a slope of 0. And that's going to be a horizontal line. 0 is always horizontal. We'll learn that positive slopes go up. That's a positive slope. Negative slopes go down, but flat slopes are equal to 0. And that's what you have here, 4, 3 and 8, 3. I'll just do it really quick. 4, 3 and 8, 3. If you draw that line, it's a flat line. It has a slope of 0. Let's do the last one. Y's minus x's. -3 minus -2. Oh, we already did that one. Or no, we didn't do that exact one. And then 4 minus -1. So this is -3 plus 2 is a -1. 4 minus a -1 is 5. So we have -1/5. And those are all of our slopes. That's how we calculate slopes containing 2 points. One final piece. If we want to graph x equals -2, there are a couple ways to think about this problem. Let's see. Let's get our graph here. That wasn't exactly good. Let's do it nice and flat. Nope, let's do it nice and flat. And let's draw our axes or our arrows. These indicate that the graph goes on forever in each direction. That I can't draw the whole thing, so I just represent that if I could, it would go off in that direction forever. Okay, now we want to graph x is -2. So one way to do it is just look at some points that have x is -2 in them. So that'd be like -2, and these things are easy. Students often can often graph more difficult things like y equals 2x minus 7, but then they struggle when they get to these ones. And these ones are actually a lot easier if you just kind of know the trick or know how to think about it. Well, x equals -2 simply means that x is always -2, but y can be anything because there's no constraint on it. So we have points like -2, 0, -2, 1, -2, 10, -2, -1. These are all points where x equals -2, right? That's all we're saying. We're just saying x is -2. Y can be anything. So -2, 0, -2, -1, -2, 10, way up here somewhere, -2, -1. So x equals anything equals a vertical line. And in this case, it's x at x equals -2. Right? So right, -1, -3, -2, -4, 1, 2, 3, 4, 5. Now y equals 5 halves, similarly, is that you can write 0, 5 halves, 1, 5 halves, or let's just do like 4, 5 halves, a -2, 5 halves. These are all points that satisfy that equation. So let's look at 0. So this is 1, 2, 3, 4, 5. So here's 0, 5 halves, which is, y equals 2.5. 4, 5 halves is right here. -2, 5 halves is right here. So here we have the line that's horizontal. So y equals anything is a horizontal line. So that's kind of the long way to think about this. Now, this is so you can do it this way. And this helps you see the answer. Let me just go really quickly and show you the quick and dirty, the faster answer. So here's the second way to do this. Here is the second way. First, if x equals, then it crosses x-axis. It crosses at the constant value. Okay, so this is the second way. This says x equals -2, so I know it crosses the x-axis, right? X equals -2, x-axis. So second, so I know it crosses this thing somewhere. Now it crosses when x is -2, so I just go, whoop, -2, boom. And I draw the line that crosses the axis. Done. Similarly, if y equals, then it crosses the y-axis. It crosses at the constant. So it crosses the y-axis somewhere where at 5, 1, 2, 3, 4, 5. 5 halves is the same as 2.5. So it crosses at 2.5. And now draw the line that crosses the y-axis. Done. And that's where we're going to leave today's. That's where we're going to leave today's lesson. We're going to leave it right there. Whoops, cool. And we're going to just stop the broadcast there. That's all the help that you need for your lesson today, your homework tomorrow, and your quiz tomorrow. We'll see you tomorrow in day 3.